Hello and welcome to my new AT&T Globalyst 590 desktop PC. A Pentium 66 MHz, one of the first generation Pentiums with 16 megabytes of RAM and 512 megabytes of storage, running Windows 95. Enclosed in a beautiful desktop case with a red power button, the Intel Inside logo, and installed with Windows 95 and Microsoft Office 95. A throwback to mid or end 1994 when this PC was released by AT&T. Now, according to this article, the Globalyst is a strong and a fairly fast contender. It had a variety of options, but with its 66 MHz Pentium CPU, it outpaced most of the 486s that were around at the time. If we look at the specs and the price, it retailed for $3,681 with 16 megabytes of RAM, half a gig of hard drive, a 2 megabyte video card, and the Intel 66 MHz Pentium based CPU. Multimedia options included a double-speed CD-ROM drive and a sound card and networking card. A reasonably well-designed machine at an affordable price. Now, mine doesn't fare well at all in the multimedia department, but we'll tackle that in a different video, where I will be installing a CD-ROM drive, a networking card, and a sound card to the system. Now, the machine didn't look exactly the way that it does now when I first got it. It was picked up by the seller at some kind of auction. It was pretty dirty. It had lots of stickers on it all over the place. It was missing the power button, but the AT&T logo really stood out and I had to have it. Now, the case needs a lot of work. It has a lot of stickers on it. It has a lot of marks on it, but it should clean up pretty nicely. I was a bit worried that the power button was gone, probably due to the fact that somebody removed the power supply, so that's the reason why we have this big gaping hole at the back of the PC. As far as I/O is concerned, we have keyboard, a nice little mouse connector, 2 serial ports, a parallel port, and a VGA connector. And on the inside, we have a expansion card here with 2 PCI slots and 5 ISA slots. So this was also sold with a sound card or a networking card, but this one doesn't have it. We have an ATI Mac 32 video card. We have 256 kilobyte of level 2 cache. We have the Intel chipset, and we have the Intel Pentium CPU with a heatsink on top of it and a fan to blow some air over the heatsink. So a nice little system. On the inside it was pretty clean. So let's take a look at the actual CPU on this thing. So as I already said, this system is equipped with an Intel Pentium 66 MHz, the first generation Pentiums. Now this is the SX950 variant of the Pentium 66. It contains an integrated heat spreader, but it doesn't contain the floating point division error, unfortunately. Now in 1994, Intel released millions of bad, flawed Pentium chips that contained this floating division error. It cost them upwards of $475 million to replace the defective CPUs, but unfortunately this one doesn't have the error. So the PC is equipped with 16 megabytes of RAM, 2 times 8 SIMs. Here we see the PC speaker. It has an integrated IDE controller and floppy controller, and the infamous Dallas RTC. Now, because the power supply unit was removed from this PC, we need to look for an alternative power supply. Now, this is an AT-based system, so it requires an AT power supply. But for this PC, I'm going to be using an ATX power supply, because ATX power supplies are typically a little bit more modern and less error prone. In order to hook up an ATX power supply to this AT-based system, we need a converter. And this is what I have here. Now the goal of such a converter is to convert the ATX format into the AT format and also provide a solution for toggling the power switch on the power supply unit. So here we have the ATX side and here we have the AT side, and we have two leads that can be hooked up to a power button. And that is because the power button on an ATX power machine works completely different from that of an AT power supply. On an ATX power supply, you simply need to bridge two contacts. So let's hook it up. We will take the AT connectors. There are two of them marked P8 and P9. We will hook them up to the main board. We need to ensure that the black cables are joined together at the center, like this. And then we can hook up our power supply. You see I have a paper clip in here. Now this paper clip is used to turn the power supply on and will be replaced by these two leads in this adapter here, so that we can hook it up to the actual power button of the case. So for now we're just going to be hooking up the adapter so that we can supply power to the main board. So as you can see here, I've bridged the two connectors, the green and the black one. I have an MS-DOS boot floppy, so let's see if we can start the system now. So we'll attach the power cable to the power supply unit, turn it on, and nothing happens. So that's a bit of a bummer, but I did notice when I was wiggling this power connector, I would hear a fan turning on in the case, and when I rebooted the PC, all of a sudden I noticed that it was booting. So it must have been some kind of bad connection somewhere. So despite the fact that I saw the PC booting, it detected my keyboard. It obviously didn't detect a hard drive or a battery, because the battery is dead and there is no hard drive in the system. I did have some difficulty entering the setup, because I noticed that the PC would simply hang when I pressed F1. So when I rebooted the PC again, I decided to continue with the boot and not enter the BIOS. So I had my MS-DOS floppy ready. So it takes a while to initialize everything, because it's probably searching for the hard drive right now. But it does give you the option to boot by pressing escape. So when pressing escape, it picked up my disk and it booted into MS-DOS just fine. So that was already a small victory. Now at this point I was pretty confident that the PC would work, but we needed to tackle the power button. So on an AT-based system, the power button is typically included with the power supply. So when the power supply is gone, the actual button itself is typically also removed. But I was a bit worried that the plastic cover of that button that should extrude through the case was also lost. But luckily, when I removed the front cover of the PC, as I needed to clean it anyway, I noticed that the red button was lying there. So yeah, luckily this didn't get lost, and I will be able to recover that in this build. So an AT power supply uses a button like this to switch on the power supply. This type of button has 4 terminals, 2 on each side, that are bridged together when the button is pushed in. So as we can see with our multimeter, we have a contact when it's pushed in. Now on an AT power supply, this is directly connected to mains voltage. On an ATX power supply, this is not the case. An ATX power supply, once you've already converted into DC, you only need to bridge 2 contacts on the ATX connector itself. So what we're going to be doing here is we're going to be using our button. We're going to attach it to the case and hook it up to the ATX power supply connector. So that way, when we push in the button, it will short the 2 contacts on the ATX power supply, effectively turning on the power supply. So here I'm just checking with my multimeter if pressing the button will actually short the 2 pins on the ATX power supply in order to boot the system. And I will put the cover onto the button. So with that out of the way, it's time to insert the ATX power supply into the case. Yeah, the layout of the case is a bit awkward because the ID connectors will now be placed beneath the power supply, so they become difficult to access. But yeah, now we're just hooking up the ATX power supply to the ATX adapter. We'll put the power supply in place, and I'm also going to be adding this hard drive. It's an IDE hard drive that I had lying around. This is a 20 gig hard drive, but the computer actually only sees 512 megabytes of it due to BIOS limitations that I cannot overcome here. So I'm just going to be adding a hard drive, and I'm going to be attaching the floppy drive cable again as well here. I'm going to be adding the power to the floppy drive and to the hard drive. And while we're in here, I'm going to be detaching the case fan and remove this so that we can clean it a little bit. Although it's in pretty good condition. But the front of the case is pretty dirty, so I'm just going to be cleaning this. In the meantime, I've also cleaned the front cover, so I'm going to be reattaching that to the case. It's just a matter of putting the LEDs back in place and making sure that the red power button slides into place. So giving the front cover a little bit of a cleaning and putting the power button back in place gives the PC a totally different and new kind of look and feel that I really like. Next up is the case cover, which is full of this horrible plastic glued onto it from the auction. This is a big mess. It's a horrible thing to remove, so this will require some additional cleaning. And it's all over the place, so yeah, probably gonna be needing some extra time to get rid of all this goo which is now sitting on the case cover. And this thing is really sticky. So all in all, I'm really happy how this build turned out. I was lucky enough that the PC still worked. I only needed to replace or to install a power supply, recuperate the power button and switch, and the machine was pretty much good to go. I was able to install Windows 95 without any issues. It only recognizes hard drives up to 512 megabytes. That's a bit of a bummer, but yeah, I'm not going to be too worried about that. This is an excellent machine for Windows 95, but I really love the look and feel of this desktop case. So I hope you've enjoyed this quick introduction into my new AT&T Globalyst 590. If you did, please give it a thumbs up, subscribe, hit the notification button so that you are informed of new videos, and I hope to see you guys soon. Bye bye, take care.